So last time we had introduced the concept of energies and we looked at specific heat times mass times temperature change gives us heat, or heat capacity times temperature change gives us heat. Now we've done a couple of problems. Now this one's really fancy. My goal is to get out of here and be able to have the test on Tuesday. So this is a take-home quiz. Because we won't have a quiz in class Tuesday, hopefully we'll be having a test. So it's a take-home quiz. Bring it on a full sheet of paper, or if you want to finish it on here, just put your name on the top. Bring it in, I'll grade it on here. I will be available to you early on Tuesday. If you'd like, I can come down to the corner of the hallway where you all hang out and give you feedback there, rather than just sit in my office and wait for you to come to me. So do this problem at home. So now we'll use these same concepts to talk about another kind of heat generating reaction, and that's what's done in a calorimeter. Constant volume calorimeter, that is a bomb calorimeter. We have a small contained little vessel. Put something inside it, burn it, and measure the temperature change of the system. And then we can figure out how much heat was generated. That's how they find calorie content of foods. When you look on food packages and it says this has so many calories, they got that by burning that in a bomb calorimeter. So we look at this one. 5.8 grams of cereal was burned in a bomb calorimeter, heat capacity of 43.7 kilojoules per degree C. Temperature in the water increased by 1.92 degrees C. Calculate the energy content in kilojoules per gram. So when you look at this information, I know the grams of cereal. So if I can find the kilojoules of heat that was liberated, then I can just divide those two numbers and solve this problem. So if I look at this, we know that heat is equal to heat capacity times the temperature change, delta T. So all I have to do is slap the numbers in. Heat capacity, 43.7 kilojoules per degree C, times the temperature change, 1.92 degrees Celsius, and that gives me my heat, 83.9 kilojoules. Now, that's about as easy as the problems get because all the information is in front of you and you multiply. Now I want kilojoules per gram of cereal. So 83.9 kilojoules divided by 5.80 grams of cereal will give me the units I want, kilojoules per gram, 14.5 kilojoules per gram. So that is fairly typical of one of the lower level problems that you would expect to see on the test or quiz. That would be one of the single concept problems where we're just checking to see, did you get what we talked about in class? Okay, this is another one that's kind of similar. So let's work through this one as a group. The energy content of raisin bread is 13.1 kilojoules per gram. What will the change in temperature be? So we're trying to find delta T, that's our unknown. When we burn 32 grams of bread and the calorimeter has a heat capacity of 39.97 kilojoules per degree C. So how would you start this? Kind of backwards, right? And sometimes you can go kind of backwards, do it in steps. Sometimes these lend themselves to just doing it like a fence post where you just combine the units. When you look at this one for units, we want our answer in degrees Celsius, temperature change. And you look at what we know kilojoules per gram. We know grams, 32 grams of bread. And we know kilojoules per degree C. So when you look at that information, we can use this. I think the easiest way to do this one is in a fence post. Okay? So if we look at this, we know that we have 32 grams of bread. And we know that the energy content is 13.1 kilojoules per gram. So that tells me how many kilojoules I have. And I know information about kilojoules per degree Celsius. Right now my unit's in kilojoules. So if I look at this and say 1 degree Celsius change is 39.97 kilojoules, I'm kind of going backwards and kind of just using the units to do it in a fence post. So whatever way seems more logical to you is the way that you should approach it. So this gives us our information, 10.5 degrees Celsius. I think that's the easiest way to do this one. You could also have tried to set it up algebraically and done it differently, but I think that's easiest. So do you have questions about calorimetry problems where you're given information on heat capacity and mass and maybe asked to divide two numbers? Okay, then we're going to look next at Hess's law.